Hey everyone! Today we're going to be working on quadratic word problems, and in particular, these are going to be profit optimization. So, I'm going to read it through, and we're going to highlight key information. Here at Workshop 49, we are selling cupcakes. Cupcakes. When we were selling them at $3, we were selling 200 cupcakes. We noticed that if we increase the price by 10 cents, that we sold 5 fewer. And vice versa. Vice versa means that if we decrease the price by 10 cents, we would actually sell 5 more. At what price should we sell cupcakes to make the greatest profit? Well, if we want to make a profit equation will look like this, where our profit will equal the cost per sale multiplied by the number sold. So if we don't adjust this price at all, how much money will we make? Well, we sell them for $3 each, that's our cost, and we sell 200 of them, that's our number sold, we would make $600. However, we're going to introduce a variable called x, which equals price adjustments. Price adjustments. And these adjustments are going to be 10-cent increments. And each time we adjust our price, we're going to sell more product or less product. And we're going to see how we make the most amount of money. A profit equation, I'm just going to draw a quick little sketch here, kind of looks like this, where if you adjust your price so many times down, eventually you make no money because you've set your price to $0 and you can sell as many as you want. You'll go broke because you make nothing per sale. Or we go the other way and we increase the price so much that no one wants to buy it. And then again, you make no money. In between, we have something that looks like this. Ooh, it's our little parabola shape. Ideally, we want to sell our product right there. That is the point where our profit is going to be highest. If we reduce our price too many times, we make nothing. If we increase our price too many times, we make nothing. Right here, we make the most amount of money. And for those of you who have been paying attention to your quadratics and are now just working on word problems, I should hope that you recognize that point right there is the vertex. In this problem, we are looking for the vertex. We are trying to maximize our price. So let's write this out and see what we get. Our price equation will become P is equal to our cost per sale is our 3 plus, to write 10 cents, that's a 0.1, because it's 0.1 of a dollar, multiplied by x. If we adjust our price no times, x is 0, 0.1 times 0 is just 0, so it's 3. If we adjusted our price 10 times, it would be this 0.1 times 10, which is a whole dollar, which would make it 4. That's how this x is going to work. On the other side, our number sold is 200 subtract 5x. X again is price adjustments, and every time we adjust our price, we lose 5 sales. If we adjust our price once, we lose 5. If we adjust our price twice, we lose 10, and so on. To find the vertex of this, I am going to expand it out by foiling it, and we are going to end up with 600 plus 20x minus 15x minus 0.5x squared. And if anyone wants help with how to expand factors and FOIL it out, I can absolutely make a video on that to help you out. But for now, we're working on the quadratic word problems, so we'll assume there's a little bit of background information here. I'm going to clean this up, and it's going to look like negative 0.5 x squared plus 5x plus 600. All right, we got a nice looking quadratic here. How do we get the vertex? We're going to use our vertex equation, which is x equals negative b over 2a. X is equal to our b value. In this case, that's the number in front of the x. That's a 5. So we get a negative 5 over 2 times our a value, which is negative 0.5. Negative 0.5. I was going to clean up this line here. We divide that out, and we get x equals 5. Hooray! The most common mistake that I see folks making at this point is they go on to tell me I should sell it for $5. It's not $5. That 5 represents price adjustments. That means I should adjust my price 5 times. Each time we adjust our price, we're adjusting it by 10 cents. So it actually looks like 3 plus 0.1 times 5, which is equal to 3.5. Our final answer is $3.50. $3.50 is what we should sell our cupcakes for, delicious that they are, in order to make the greatest amount of profit. X is price increments, not the final price. I'm going to do another example here, and hopefully if you are following along, this one should be even a little bit easier. So let's scroll down, and I've made a new one that's pretty similar, but we're going to go ahead and start off by highlighting key information. We're not selling cupcakes this time, we're selling something that I can't imagine that I would ever sell. Here at Workshop 49, we are selling tickets to listen to me sing. No one's going to buy these, but we're going to try and sell them anyway. If we were selling them at $500, we would expect to sell 100 tickets. So that's our initial cost per item. This is our initial amount sold. With a survey we completed, we noticed that for every price increase of $5, that's our increment value. If we adjust our price, we're adjusting it by $5, we would sell 2 fewer tickets. That's the adjustment to our number sold. Again, vice versa. If we decrease our price by $5, we would actually sell 2 more tickets. At what price should we sell these tickets to make the greatest profit? Our profit, I'll write this out again, is going to equal the cost per sale multiplied by the number sold. With our X being equal to price adjustments. So our X is our price adjustments, not our final cost. Our X is going to be the number of times that we adjust our price. And every time we adjust our price, it goes up by $5 and down by 2 sales. Our profit equals our cost per sale, $500 plus 5x, $5 every time we increase our price. Our number sold is going to be 100 minus 2x. It's minus 2x because every time we adjust our price, we sell 2 fewer tickets. I was going to move this up a little bit to give me some space, and let's go ahead and expand this out and FOIL this one out. So my profit is going to equal 50,000 minus 1,000x plus 500x minus 10x squared. And I'm going to clean this up a little bit. My profit is going to equal negative 10x squared minus 500x. I'm just combining these 2 terms in the middle, and I like to put my x squared in front. It gets it into nice looking standard form, plus 50,000. We are looking for that maximum value. The maximum value is we need the vertex. In profit optimization, we are always looking for the vertex. Our vertex equation, x equals negative b over 2a. X equals the negative of negative 500. Watch that. This b value is negative. It's a negative b. That's going to become a positive 500. Divided by 2 times negative 10. Our final answer is going to equal negative 25. Negative 25. But remember, that x value is not the price that we should be selling at. That's the number of price adjustments. So we can fill this back into our cost per sale. 500 plus 5 times negative 25. Oh, that negative 25 means instead of adjusting our price up 25 times, we're actually better off adjusting our price down 25 times. What we're going to solve this to be is 375, which means that the best price to sell these tickets for everyone to come and listen to me sing is going to be $375. And that is how we do a quadratic profit optimization problem. I hope that this was helpful. Cheers!